This video, we will solve further problems from exercise 3.4. Question number 21. Prove that cot of A plus B is equal to cot A cot B minus 1 divided by cot A plus cot B. Now, we know that tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. Now, cot A plus B is nothing but cot is 1 by tan. So, it's 1 by tan of A plus B. So, we have tan of A plus B here. So, let's replace it here. So, basically, this will be the reciprocal of this here. So, this will be, the denominator will come to the numerator. So, it will become 1 minus tan A tan B divided by tan A plus tan B. What we need to prove that this is in terms of cot. So, let's change all the tan to cot. So, tan is 1 by cot. So, this will become 1 minus 1 by cot A into 1 by cot B divided by 1 by cot A plus 1 by cot B. So, let's take cot A cot B as the denominator for the numerator. So, the numerator will now become cot A cot B. Therefore, the 1 here will become cot A cot B. Cot A cot B minus 1 into 1 is 1 divided by, here this will be cot B plus cot A. So, you will cross multiply like this and have the denominator as cot A cot B. So, the denominator here will be cot A, which is the denominator of the denominator, and the numerator of the denominator will be cot B plus cot A. Now, you can see that these two terms are the same. So, you can cancel them and this will now become cot A cot B minus 1 divided by, you can reverse this cot B and cot A as cot A cot B. So, this will be cot A plus cot B. That's the right hand side. So, this is the left hand side is equal to this, which is equal to the right hand side for the proof. Question number 22. If tan x is equal to n by n plus 1 and tan y is equal to 1 by 2n plus 1, find tan of x plus y. So, you're given tan x, tan y, you need to find tan x plus y. So, we know that tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. Okay, let's take the numerator first. The numerator is tan x plus tan y, which is replacing the values of tan x and tan y from here. This becomes n by n plus 1 plus 1 by 2n plus 1. So, that is equal to taking n plus 1 into 2n plus 1 as the denominator. Then you will cross multiply. So, you would get n into 2n plus 1 plus 1 into n plus 1 is n plus 1. Further expanding this, this will be 2n squared plus n plus 1 and divided by n plus 1 into 2n plus 1, which is nothing but 2n squared plus 2n plus 1 divided by n plus 1 into 2n plus 1. Similarly, let's take the denominator of this expression 1. So denominator of 1, and this is, let's say, numerator of 1, is 1 minus tan x tan y, which is nothing but 1 minus n by n plus 1 into 1 by 2n plus 1. So further expanding this becomes n plus 1 into 2n plus 1. Let's separate this. Minus n divided by n plus 1 into 2n plus 1. So further expanding the numerator, you get 2n squared plus n plus 2n plus 1 minus n divided by n plus 1 into 2n plus 1. So this can be further simplified as 2n squared plus this n and n will get cancelled. So 2n plus 1 divided by n plus 1 into 2n plus 1. Now you can see that the numerator and the denominator are now equal. So if I am going to say then tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y will be equal now to, the numerator is 2n squared plus 2n plus 1 divided by n plus 1 into 2n plus 1, and the denominator is 2n squared plus 2n plus 1 divided by n plus 1 into 2n plus 1, which is, since the numerator and denominator are the same, this is equal to 1. So that's the value of tan x plus y. Question number 23. Prove that tan of pi by 4 plus theta into tan of 3 pi by 4 plus theta is equal to minus 1. So let's take the expression separately first. Let's take the tan pi by 4 plus theta. This would be equal to tan of pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta. Now let's replace the value of tan pi by 4 into this. So tan pi by 4 is 1. So this is 1 plus tan theta divided by, again, 1 minus, since tan pi by 4 is 1, this will be equal to 1 minus tan theta. Let's call this 1. Now let's take the second term, which is tan 3 pi by 4 plus theta. So that would be again equal to tan of 3 pi by 4 plus tan theta divided by 1 minus tan of 3 pi by 4 into tan theta. Okay, now let's figure out what's tan 3 pi by 4. That would be equal to tan of 3 into 180 divided by 4, which is equal to tan of, so if you cancel this, will be 45 times 3, which would be 135 degrees, which is equal to tan of 90 degrees plus 45 degrees. So this is in the second quadrant, therefore tan will be negative. So minus, and 90 plus 45 degrees will be cot 45 degrees, which is equal to minus 1. So let's put this value of tan 3 pi by 4 into this. So this will now be minus 1 plus tan theta divided by 1. Minus into minus will become plus tan theta. Okay. Now what we are asked to find is the product of 1 and 2. Let's call this 2. So from 1 and 2, we can say that tan pi by 4 plus theta into tan 3 pi by 4 plus theta is equal to 1 plus tan theta divided by 1 minus tan theta into this. We can rewrite this as tan theta minus 1. So this is tan theta minus 1. Let's put them all in brackets, divided by 1 plus tan theta. Now these two terms will disappear. So you're left with tan theta minus 1 divided by 1 minus tan theta. So if I take the minus 1 outside of this tan theta minus 1, then this will become 1 minus tan theta, because this will be minus into plus, minus 1 here, minus into minus will be plus tan theta, which is here, divided by 1 minus tan theta. So these two will be cancelled. The answer will be minus 1, which is, so this is our left hand side is now equal to the right hand side. Hence the proof. Question number 24. Find the values of tan alpha plus beta given that cot alpha is equal to 1 by 2 and alpha belongs to pi, 3 pi by 2. So this is in the third quadrant. And secant beta is equal to minus 5 by 3. And beta is in the interval pi by 2 to pi. So this is in the second quadrant. Okay. So now let us get tan alpha, because we know that if we get tan alpha and tan beta, then we'll be able to find all the values. So using cot alpha and secant beta, we are going to try and find the values of tan alpha and tan beta. So given to us, cot alpha is equal to 1 by 2. And this implies tan alpha is equal to 1 by cot alpha. So that will be equal to 2. And in the third quadrant, our tan is positive. Okay. Second, given to us, secant beta is equal to minus 5 by 3. So this would mean that cos beta is equal to 1 by secant beta. So that would be minus 3 by 5. Again, this in the second quadrant, cos is negative. Okay. So let's call this as 1 and 2. Okay. Now from 2, I can say sin beta is equal to root of 1 minus cos squared beta. Okay. This is more easier to solve rather than taking a triangle. So this would be just put the value of cos beta into this. So this will be 1 minus 9 by 25. Okay, 3 squared by 5 squared will be 9 by 25. So this is nothing but root of 25 is common, and here you have 25 minus 9. So this is equal to, this should be plus or minus and plus or minus. So this is equal to plus or minus root of 16 by 25. Now, since in the second quadrant, beta is in the second quadrant, in the second quadrant, sign is positive. So this will become 4 by 5. Okay, so let's call this 3. So from 2 and 3, our tan beta is equal to sin beta divided by cos beta, which is equal to, our sin beta is 4 by 5 divided by minus 3 by 5. So that's equal to 5 and 5 will be cancelled. So you'll be left with minus 4 by 3. Again, it's in the beta is in the second quadrant and tan is negative. Okay. So let's call this 4. So now we have tan alpha from 1 and tan beta from 2. So from 1 and 4, we can say tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta, which is equal to, my tan alpha is 2. 2 plus tan beta is minus 4 by 3. Minus 4 by 3 divided by 1 minus of 2 into minus 4 by 3. So further, taking 3 as the denominator for the numerator, 3 into 2 will be 6. Plus into minus will be minus, so minus 4 divided by, again taking 3 as a common denominator here, 3 into 1 will be 3, minus into minus will be plus, 2 into 4 is 8. So your answer here is 2 by 3 divided by 11 by 3. 3 and 3 will get cancelled. So your tan alpha plus beta will be 2 by 11. Question number 25. If theta plus phi is equal to alpha and tan theta is equal to k tan phi, then prove that sine theta minus phi is equal to k minus 1 divided by k plus 1 into sine alpha. Now given to us, what is given? Theta plus phi is equal to alpha and tan theta is equal to k tan phi. So we can rewrite this as k is equal to tan theta divided by tan phi. Now in the right hand side of the to prove, we have k minus 1 and k plus 1. So using this k, let's define k minus 1. So k minus 1 will be tan theta divided by tan phi minus 1, which will be equal to tan phi tan theta minus tan phi. And our k plus 1 is equal to tan theta divided by tan phi plus 1. So that would be equal to tan phi tan theta plus tan Okay, so now from here we can say that k minus 1 divided by k plus 1 will be equal to tan theta minus tan phi divided by tan phi divided by k plus 1 is tan theta plus tan phi. Let me write the division here, tan phi. So these two terms, tan phi and tan phi, will disappear. So you'll be left with tan theta minus tan phi divided by tan theta plus tan phi. Now further, let's substitute sine cos for tan. So this numerator will now become sine theta divided by cos theta minus tan phi will be sine phi divided by cos phi divided by this tan theta will now become sine theta divided by cos theta plus tan phi will now become sine phi divided by cos phi. Okay, so let's write them here now. So now the denominator will be cos theta and cos phi. So the numerator we need to cross multiply. So numerator will now become sine theta cos phi minus sine phi cos theta. This is divided by cos theta cos phi. Cos theta cos phi. This whole thing is divided by. Now let's go to the denominator. Again, by cross multiplying and taking the denominator as cos theta cos phi, the numerator will now become, the numerator of the denominator will now become sine theta cos phi plus sine phi cos theta divided by cos theta into cos phi. Now these two denominators are the same, so they will disappear. So you'll be left with sine theta cos phi minus sine phi cos theta divided by sine theta cos phi plus sine phi cos theta. Now this is nothing but sine theta minus phi, and this is sine theta plus phi. So this we can write the numerator now as sine theta minus phi divided by sine theta plus phi. Okay, now what is given is, we are given that theta plus phi is alpha. So replacing that onto this, you get sine theta minus phi divided by sine alpha. Okay, so this is k minus 1 by k plus 1. Okay, so this would mean from this, if you take sine alpha to the other side, sine theta minus phi is equal to k minus 1 by k plus 1, k minus 1 by k plus 1, and sine alpha will go to the other side. So this will become sine alpha. And this is what we need to prove. Hence the proof. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.